So today we are going to do the next exercise, that is exercise 2.3. So last two videos you must have already seen of the polynomials. If you haven't, please do watch that because it's important that we understand the basics first and then proceed in sequence. So right now we are going to proceed with factorization of polynomials. In factorization, we should know the method which you did in class 8, that is splitting the middle term. Factorization by splitting the middle term. You should know your basic identities which you did. Factorization because can be based on those identities which you did, a plus b whole square, a square minus b square, a minus b whole square, and so on. We will also be doing the factor theorem and the remainder theorem, right? And using these methods, we have to do the exercise, and I'm going to explain one by one what is the procedure to do these questions. So I'm going to start with the first question of the third exercise 2.3. So exercise 2.3, determine which of the following has x plus 1 as a factor. Now we have to find out whether x plus 1 is a factor of this. Now, how do we find out whether it's a factor? When the remainder is 0. So suppose I want to find out whether 2 is a factor of 10. I'm going to divide 10 by 2. And if the remainder is coming 0, I can say 2 is a factor, isn't it? So whenever we are going to find out the remainder by division and remainder is 0, then that is the remainder theorem, that if the remainder is 0, then we can say it's a factor. So here I explained on the basis of long division, but when I'm going to divide polynomials, that becomes long. So we have something called the remainder theorem or the factor theorem, where the value of x can be taken out from here and substitute here just to find out what the remainder is. If the remainder is 0, then we can say that it is a factor. And if the remainder is not 0, then it is not a factor. So here, when I am taking x plus 1, I'm going to get x plus 1 as 0. The value of x's will be negative 1. Okay, the value of x I'm going to get negative 1. So what I need to do is I'm going to substitute this in the first part. So minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. What have I done? I've taken out the value of x as minus 1 and I'm putting here. So this is going to become minus 1, right? This is going to become positive 1, minus 1, plus 1. So what is going to happen? We are getting remainder as 0. So the first part we can say yes, x plus 1 is a factor, right? Now it's the same procedure. We have to repeat the same procedure 4 times. Now again, x plus 1 is a factor. We have to find out. So put the value of x as minus 1 in this. So second one will become minus 1 to the power 4, minus 1 to the power 3, minus 1 square, minus 1 plus 1, right? So minus 1 plus 1 I'm cancelling. Minus 1 to the power 4 is positive 1. Then this is minus 1 plus 1. So here in the end we are getting 1. Remainder is not 0. Therefore, it is not a factor. So the easy technique is to find out whether it's a factor or not, just to find out the remainder. Of course, you could have done this whole question by dividing. That becomes a long procedure. So better is to use the remainder theorem and find out whether it's a factor or not, right? So moving on to the third part. Now here, x is minus 1. I'm putting the third. So this will become minus 1 to the power 4. 3 into minus 1 cube, 3 into minus 1 whole square, minus 1 plus 1. Okay, so if you haven't done it, you can always pause the video and re-watch it till you are able to do it on your own, right? So I'm going to the third part. This is going to be minus 1 to the power 4, that's positive 1. Minus 1 cube is minus 1, so this is going to be minus 3. Minus 1 square is positive 1. 1 and 3 will give me positive 3 plus 1, right? So here what has happened is negative 3 and positive 3 is getting cancelled. But if you notice here, this is positive 1, this is positive 1, we are getting remainder as 2. So since remainder is not 0, the x plus 1 is not a factor of this. It is not a factor. Okay, that's the third part. So the same procedure now I'm repeating in 4. I'm putting x as negative 1. So minus 1 whole cube, minus of minus 1 square, minus of 2 plus root 2, bracket minus 1 plus root 2. Now this, you have to be a little careful here. because of the brackets involved. So again, I'm repeating, putting x as -1, -1 cube, then there's a negative, don't change any symbols which are there here, -1, -1 whole square, -2 plus √2, value of x I'm putting -1 plus √2. Now -1 whole cube is -1. When I square -1 whole square, I'm getting +1, but there's a negative outside, so this will be -1. Now here you have to be very careful here. There is a minus here and there is a minus here. So minus and minus, when I multiply this is going to become +1. Okay, so I can write this as +1. I am not opening this right now. I am just multiplying the negative and making it positive. 2 plus √2 as it is, plus √2. So -1 -2. Then when you open the bracket, 1 into anything is the number itself. So this will remain as it is. +2 -2 gets cancelled. √2 we get 2 √2. Remainder is not 0. Therefore, this is also not a factor. So this is how we do this question, finding out whether it's a factor or not. Then same, using factor theorem, find out whether gx is a factor of px. So gx is x plus 1. So x value is going to be -1. And put the value here, we get x as -1. Let's see whether it's coming 0 or not. So 2 into -1 cube plus -1 square minus 2 into -1 -1. Okay, what are we doing? We are putting the value of x as -1. So 2 into, this is -1, -1 square will become +1. This is +2 -1. So -2, -1 and +1 is getting cancelled. We get -2 plus 2, which is 0. So here I can say, yes, x plus 1 is a factor of px, right? Or gx is a factor of px. So here the question was, find out whether gx is a factor of px. Question number 2, second part. Now we have to find out whether x plus 2 is a factor. So if I'm taking x plus 2, x value is -2, put the value of x as -2 here. So this is -2 cube, 3 into -2 square, plus 3 into -2 plus 1. What am I doing? I'm putting the value of x as -2 here. So this is going to be -8. 2 square is 4, 4 things are 12, -6 and plus 1. What have I done? Put the value of x as -2 here. -2 cube, -2 into -2 into -2, you get -8. -2 square is 4, 4 things are 12, right? And here I'm getting -6 and 1. So 12 and 1 is 13. -8 -6 -14. -14 and +13, you are getting -1. So I can say this is not a factor. Gx is not a factor of px. Then the last part, x minus 3. So if I'm going to check this, the value of x that you have to put is 3. So instead of x, I will put 3. So this will become 3 cube, 4 into 3 square plus 3 plus 6, right? Now 3 cube is 27, 3 square is 9, 9 4 is 36, and 9, we get 36 minus 36 is 0. Therefore, here I can say this is a factor, gx is a factor of px. So hope you understood the factor theorem. All you need to do is substitute the relevant value of x here. If the remainder is 0, then I can say it's a factor. If the remainder is not 0, it is not a factor. Right? Now we go to question number 3. Find the value of k if x minus 1 is a factor. X minus 1 is a factor, so I can say that x is 1. If it's a factor, then -1 will go the other side, x is 1. So what you need to do is put the value of x as 1 here. So I'm going to get 1 square plus 1 plus k, and I'm going to equate it to 0. Why? Because it's a factor. And just now I had told you in the previous question that if any number is a factor, and when we put that, the remainder will come 0. So it's already given factor, so we are equating to 0. So 1 plus 1 plus k is 0. K plus 2 is 0. Value of k you will get -2, right? -2. Then second part, we are going to put the value of x as 1 here. Okay. So when I'm trying out the second part, x minus 1 is 0, x value is 1, put the value here. P1 is equal to 2 into 1 square plus K into 1 plus root 2. Now, just now I told you that if it's a factor, the remainder will 0. So I can equate this to 0. So K value will be minus 2 and minus root 2. All I have to do is shift the values of 2 and root 2 to the right side. So this was the second part. Then we come to the third part, that is Px is kx square minus root 2x plus 1. Third part, I am putting again x value as 1, okay, x minus 1. This is a constant for all the four parts. So when I am putting x as 1, I'll get k into 1 square minus root 2 into 1 plus 1 is 0. So k minus root 2 plus 1 is 0, right? So here, what am I going to get? K into 1 square. 1 square is 1 itself. So k minus root 2 and plus 1. Now what is going to happen here? K will be, I'm going to shift this the other side. It will become positive root 2 plus 1 will go outside. It will become root 2 minus 1. Okay, so k value is root 2 minus 1. Then we have the last part here. When I'm putting the value of k x as 1, I'm going to get P1 is equal to k into 1 square. Then I'm going to get minus 3 into value of x we are taking as 1 plus k. So k minus 3 plus k is 0. 2k minus 3 is 0. 2k is 3. So the last answer we'll get k is 3 upon 2. Value of k will become 3 upon 2, right? Now we come to the factorization. This is factorization by splitting the middle term. So 12x square minus 7x plus 1. Okay, factorization by splitting the middle term. Very important question. Question number 4 and question number 5 are important questions. You will definitely get questions on this. Now, those of you who have forgotten splitting the middle term, you have to multiply the first and last number, right? 12x square and 1. When I multiply, I'll get the product 12x square. And the number at the center, sum, is minus 7x. So I have to think of two numbers, which on multiplying will give me 12x square, and on adding will give me minus 7x. So you have to think of two numbers, which on multiplying is 12 and adding is 7. So the required factors, you can try out various combinations like 6 2s are 12, 12 1s are 12, or 4 3s are 12. So that 4 3s are 12 is correct because I should get 4 into 3, 12, and I'm going to add minus 4 and minus 3. I'm also getting minus 7. So my factors are minus 4 and minus 3. So what I need to do is 12x square. I'm going to write here minus 4x minus 3x plus 1. Okay. Now 4x common, 3x minus 1. Minus 1 common, 3x minus 1. So if my factorization is correct, my bracket should be same. If you have done something wrong, these brackets will go wrong, right? So first and last term will remain as it is. That is why it's called splitting the middle term. Only minus 7 we are replacing with minus 4 and minus 3. Then we are taking common 2 by 2. So what is common here is 4x. So 4 goes how many times in 12? 3. X square is here. I am taking out x. So 3x is left. 4x is already out. So 1 is left. Here I am taking negative common. So this will become 3x and this will become minus 1. Why minus 1? Because when I multiply, I have to get back this. So minus 1 into 3x, minus 3x, minus 1 into minus 1, plus 1. I have to get back this. Don't put plus 1. That's a common mistake which students do. So now since the bracket is same, that means factorization is correct. I'm going to combine this. 3x minus 1 is common. So what is left is 4x minus 1. So answer will be 3x minus 1, 4x minus 1. Right? So I hope you've understood this. So the same procedure we have to apply in the second, third, and fourth parts. So in the second part now, 2x square plus 7x plus 3. Multiply the first and last. The product is going to be 6x square. When I add, I'll get the number at the center, that is 7x. So think of two numbers, which on multiplying gives me 6 and on adding will give me 7. Which two numbers are there? The numbers are 6 and 1. 6 into 1 is 6 and 6 plus 1 is 7, right? Some people may think 4 and 3. No, 4 and 3 will give you 7, but 4 into 3 is 12. You need to satisfy both the condition that product is 6 and sum is 7. So as I told you, the first and last number remains as it is. Only the middle term gets split. So I'm going to split this as 6x and 1x. So 2x is common. Now this will become x plus 2 goes 3 times here, 3. I'm going to take 1 common here, x plus 3. So you are going to get the answer x plus 3 into 2x plus 1, right? So answer will be x plus 3, 2x plus 1. This is answer number 2. Then answer number 3, that is 6x square. 6x square plus 5x minus 6. When I multiply the first and last, the product is coming minus 36. When I add, I'm going to get 5x. So what are my factors here? When I multiply, I should get 36. When I add, I should get 5. So my factors are 9 and minus 4. 9 into 4 is 36. 9 into minus 4 is minus 36. And 9 minus 4 will give me 5, right? So both the conditions are being satisfied. So I'm going to write the first as it is. Middle term I'm splitting. What is common in 6 and 9 is 3. And x square and x common is x. 3 goes 2 times. So I'm going to get 2x plus 3. Minus 2 common, 2x plus 3. Combine this, we get 2x plus 3 into 3x minus 2. So we get final factors 2x plus 3 and 3x minus 2, right? Both the brackets are coming same. That means my factorization is correct. Then the last part, 3x squared minus x minus 4. Okay, 3x squared minus x minus 4. Multiply the first and last, product is coming minus 12x squared. And when I add, I should get minus x. So my factors now will be minus 4 and plus 3. Because minus 4 and plus 3, when I multiply this, I'll get negative 12. And minus 4 and plus 3, when I add, I'm getting negative 1. Okay. So factors will be 3x squared minus 4x plus 3x minus 4. Now what is common here is x. So we get 3x minus 4 plus 1, 3x minus 4. Combine this, we get 3x minus 4. Okay. If nothing is common, always 1 is common. Don't write 0 here. 1 is always common. So when I take out 1, the numbers will be as it is. So brackets are same. I'll take it out. And what is left here is x plus 1. So this is called factorization by splitting the middle term. This is very important. Now we come to question number 5. Again, important. So here, this factorization is cubic, x cube minus, this is the first part of question 5, minus 2x squared minus x plus 2, right? In this question, what happens is the coefficient is 1. Here the coefficient is negative 2. Okay, 1, negative 2. Coefficient here is minus 1, coefficient here is 2. There is a series here, 1, 2, 1, 2. So whenever there is a series like this, 1, 2, 1, 2, 1, 3, 1, 3, 2, 3, 2, 3, like that, then we can do by taking common. So what is common in the first and second? So if I take common here, I'll get x square common. So what is left here is x minus 2. Take minus 1 common, we get x minus 2. Both the brackets are coming same, right? I'll take minus 1. So x minus 2 will come here. Because when I open the bracket, I should get the same, right? That's why I'm putting negative here. Minus and minus should come plus. Now combine this x minus 2 into x square minus 1. So x minus 2 here is your class 8, you have done identity, a square minus b square. So I can write x square minus 1 can be written as 1 square because you know that 1 into 1 is 1. So you get x minus 2, a square minus b square, answer is a plus b, a minus b, isn't it? So you are getting how many factors? 3. When it was a quadratic, we were getting 2 factors. Now it's cubic polynomial. Cubic polynomial will be 3 factors. So answer will be x minus 1, x plus 1, x minus 2. So this is how we do the cubic polynomial. This is called factorization by taking common. But this worked because the coefficients are in a definite pattern. It may not work always. Like in this, if you do the second, here the coefficient is 1, minus 3, minus 9, minus 5. So this method will not work in this. So here we are going to use another method which is called hit and trial. So this comes for 5 marks. So it's a very, very important sum. So this I'm going to show on a full page because this will require more space. So I'm doing the second question now, question number, second part of question number 5. Okay, so that question was, if you remember, x cube minus 3x squared minus 9x minus 5. Okay, so x cube minus 3x squared minus 9x minus 5. I'm going to explain how to do this. We can, as I said, we cannot do by taking common. So what we need to do is that we have to substitute a value of x such that when I substitute x as 1, it will come 0. So how do I know which values to substitute? See, the last number is 5. The factors of 5 are 1, minus 1, 5, and minus 5, right? So you have to try only these 4 numbers. Whatever the factors of this are, 5 can be only 1 and 5. If it was, let's say, a number 6, then you will have to try 1, 2, 3, and 6, etc. If the number was 10, you will try 1, 2, 5, and 10. If the number is 2, you have to try 1 and 2 combinations. So at the moment it is 5. So I'm going to try out this 1, minus 1, 5, and minus 5. So if I put x as 1, if x is 1, then this will become 1 cube minus 3 into 1 square minus 9 into 1 minus 5. So this is going to be 1 minus 3 minus 9 minus 5, right? I'm putting x as 1. So 1 minus 17, I'm getting negative 16. So this is not coming as 0 of this polynomial, right? So I have to do this till I get 0. So I'm going to take the next value, that is negative 1. So what am I going to do? I'm going to substitute x as minus 1 now, and let's see whether it is coming 0. So I have substituted wherever there was x, I am putting negative 1. So this is minus 1. Minus 1 whole square is 1. 1 into minus 3, you will get minus 3. Minus 9 minus 1, you will get positive 9 minus 5. So here we are getting 9 minus 9, that is coming 0. So I have got 0 in the second step here. So I have to keep repeating this till I get 0, at least 1. Okay, so I am getting x as negative 1. So if x is negative 1, I'll bring the negative 1 to the left. I will say, therefore, x plus 1 is a factor. Therefore, x plus 1 is a factor, right? So if x plus 1 is a factor, now what happens? I am going to divide this by x plus 1. Okay, one factor you get. How do you know the other factors? By dividing this. So suppose I know that 2 is a factor of 10. What is the other factor? 10 divided by 2, 5. Okay, by dividing 10 by 2, I'll get the other factor. So the technique to find out other factor is by dividing. So I'm going to divide the whole polynomial x cube minus 3x squared minus 9x minus 5 by x plus 1. Why x plus 1? Because x plus 1 was a factor. How did I get x plus 1 as a factor? Because x is minus 1. I got 0 here. So how to divide now? See here carefully. The first number here is x cube. First number here is x. So x will be multiplied by which number to get x cube? X into x square is going to give us x cube, right? X into x square is x cube. Okay, the powers are added. Then you are going to multiply 1 with x square. 1 into x square is 1x square. So see the step, x into x square is x cube. I have to get the exact number. And I don't leave it here. I have to multiply 1 also with x square. So I get 1x square. Now I'm going to subtract this. Always subtract. So this will get cancelled. X cube minus x cube. Minus 3x square and minus 1x square, we'll get minus 4x square. Bring down the numbers from top, minus 9x minus 5. Now x will be multiplied by which number to get minus 4x square? That is what we have to see. X will be multiplied with minus 4x. So x into minus 4x will get minus 4x square. 1 into minus 4x will get minus 4x. So same number has to be multiplied by both x and 1. Here, of course, the signs will change. When I'm changing the sign, put it in brackets so you don't get confused which was the original one and which is the changed one. Okay, because all the operations we have to do as per the changed sign. This is minus, so now I'm going to put plus. So this is getting cancelled. Minus 9 and plus 4, we get minus 5x minus 5. Now x will go how many times in minus 5x? It will go minus 5 times. So minus 5x, 1 into minus 5, minus 5. And what has happened? Signs will change. This will get cancelled and we get the remainder 0. Remainder has to come 0 because it's a factor. If you are not getting 0, that means you have to check your calculation, because if once you prove that it is a factor, the remainder has to come 0. Now, once we do this, the remainder is 0. The quotient is x square minus 4x minus 5. You have to do the splitting, which we just now did in the previous question. So when I'm multiplying, I'm getting minus 5x square. right? And when I add, I should get minus 4x. So I should think of two numbers which on multiplying will give me minus 5 and on adding will give me minus 4. So what are the factors here? My factors will be minus 5x and plus 1x. Because when I multiply minus 5 and plus 1, I'll get minus 5x squared. When I add minus 5x and plus 1x, I'll get minus 4x. So my factors are minus 5x plus 1x. First number and last number remains as it is. X common x minus 5, 1 common x minus 5. Combine this, we get x minus 5 and x plus 1. So what is the final answer that I will get? I had already got x plus 1 as a factor. Now I'm getting two more factors, x plus 1 and x minus 5. Now some people think that x plus 1 should not be repeated, we can write only once. No. See, what are the factors of 8? 2 into 2 into 2. I'm writing it 3 times, right? So whenever you are having even repeated factors, that should be written, because when we are multiplying these 3 brackets, then only we will get this polynomial. So even if the factors are same, please write it. Okay. So final answer, you will get x plus 1, x plus 1, x minus 5. So this is a very, very important question and very likely to be asked in the exam. There is also a solved example given in the textbook, that is example number 10. So you should try example number 10 as a homework. It is there, this type of question. You can repeat this procedure and try to do it, right? Now we go to the next one. That is the third one here. X cube plus 13, x square plus 32, x plus 20. Again, we are going to use the hit and trial method. So I'm going to use the same method as we did just now. So third part. Those who didn't understand the second can understand the third. I'm repeating the whole procedure for the third part as well. So I told you the last number is 20. So what are the factors of 20? 1, minus 1, 2, minus 2. 3 doesn't go, 4, minus 4, 5, minus 5, 10, minus 10, and 20. So these are the factors which are for the last number 20. So I'm going to start with x is 1. Actually, there's no point of starting with x is 1. The reason being all are positive numbers, so it will never be 0. So we can start with x as negative 1. So when I start x as, so let x is minus 1, minus 1 cube, 13 into minus 1 square, 32 into minus 1 plus 20. Okay. So this is minus 1. This is going to be minus 1 whole square is positive 1. So this is positive 13, minus 32 plus 20. 20 and 13 is giving me 33. Minus 1 minus 32 is minus 33. It's coming 0. So here I've got the remainder 0, which means that x is minus 1 is a solution of this. Therefore, I can say x plus 1 is a factor. If x plus 1 is a factor, just like the previous question, now I'm going to do the long division. I will divide x cube plus 13x square plus 32x plus 20 by x plus 1 and get the quotient. Remainder has to be 0. So x goes how many times? X square times. So x into x square, x cube. 1 into x square is 1x square. Then we subtract, the sign will change. X cube cancels. 13 minus 1, we get 12x square. Bring down the numbers from the top as it is, 32x and 20. See the first number here, x. Then the next number here is 12x square. X will go how many times? 12x times. So 12x square, 1 into 12x, 12x. Right? Now I'm going to subtract again, 12x square cancels. 32 minus 12, we get 20. 20x plus 20. So x goes how many times? 20 times. So 20, x into 20 is 20x. 1 into 20 is 20. So as I told you, if you're not able to catch up with the pace, always you have the option of playing this video slowly, or you can always pause. So these are various options available to you when you are attending this online class. This, whenever you suppose after 1 month you forget this method and you want to refer to this, you can always come back to this playlist and play this n number of times and learn how to do these sums. Okay, so here remainder is 0. So quotient is x square plus 12x plus 20. Okay, so what did I tell you? That if suppose your remainder is 0, that means your division is correct. Now I'm going to split this. So when I multiply, I have to get the product as 20x square. And when I add, I should get 12x. So think of two numbers which on multiplying will give me 20, on adding will give me 12. So x square plus 10 and 2 will be my factors, right? 10 2s are 20 and 10 plus 2 is 12. So 10x plus 2x, this is the factor. X common x plus 10, 2 common x plus 10. So I'll combine this, I'll get x plus 10 and x plus 2. So what is my final answer? I had got x plus 1 as a factor. There will be 3 factors because it's a cubic equation. So x plus 1 is one factor. Now we've got 2 more, x plus 2 and x plus 10. So final answer of this question, x plus 1, x plus 2, x plus 10. So this again is a very important question which can be asked for 5 marks, right? So both question part 2 and part 3 are very important. They're a little long, so you need to probably practice this. Then we come to the last part of question 5. Here you have an advantage because, as I said, the coefficients are in a pattern. 2, here it is 1, minus 2, minus 1. When there is a pattern, you can factorize like this, as we did the first part. That is factorization by taking common. When there is no pattern, then you have to do hit and try method. So here what is common? Y square. What is left here is 2y plus 1 minus 2y minus 1 is common. So we get 2y plus 1. So you see the brackets are coming same. So we can combine this. We get 2y plus 1 and y square minus 1. 2y plus 1, and as you have done in class 9, this is a square minus b square identity because 1 can be written as 1 square, right? And a square minus b square is a plus b, a minus b. So what happens? Your answer will come 2y plus 1, y plus 1, y minus 1. So we've got 3 factors for a cubic polynomial. We've got y plus 1, y minus 1, and 2y plus 1. So question number 4 and 5, again, I'm telling you this is important. Please go through this. And in the next class, we'll be starting algebraic identities.